So today, assignment number 2, we're going to be solving systems like we did yesterday by graphing, only this time we're going to solve them using substitution. And so it's a different method. I think you'll like it probably better than graphing. So if you want to watch this video, if you go to the PowerPoint and watch this video, might give you a little bit of a tease into this first problem, which is about Metropolis and Gotham. So Metropolis is the home city for Superman. Gotham's the home city for Batman. And so population right now of Metropolis is 145,000 people, but it's growing at a rate of 11,000 people per year. Must be that Superman's there, he's pretty popular, people want to see him. So we want to write an equation for the population of Metropolis. So this is 11,000 people per year. That's our slope. That's how it's changing. And it's starting with a population of 145,000. That's our y-intercept. So that goes back to our last chapter on linear equations. And so our equation looks something like this. 11,000 times x. So 11,000 every year, plus it started with 145,000 people. Now, that's different than what's going on in Gotham. So Gotham's a dark city. It's much bigger right now than Metropolis. 349,000 people live there, but people are moving away. It's losing population at a rate of 6,000 people per year. And so this is the slope, and it's negative because it's losing 6,000 people per year. So here the equation is going to be y equals negative 6,000 times x plus the current population, which is 349,000 people. And so those are the populations of the two cities. We have these two equations. One for Metropolis that's growing at 11,000 people per year, but it's pretty small, 145,000. Gotham is losing 6,000 people per year, but it's pretty big, 349,000 people per year. So here's our question. When will the populations of both cities be the same? Well, one way we could solve this question is by graphing it. If I were to graph Metropolis, it would look something like this. Right now the population is rather small, but it's growing up at 11,000 people per year. It's a positive slope. Gotham is over twice as big as what Metropolis is. So Gotham's population is up here, but it's decreasing 6,000 people per year, and so it's going down. And what we want to know is, when will the two cities have the same population? For a while, we know for a certain number of years, Gotham's going to remain bigger, but if these rates continue, they're going to be the same. So here's what we're going to do. We have the population of Metropolis, which is what y is. So we have y is this expression, 11,000 times x plus 145,000. What I'm going to do is take this expression, which is equal to y, and I'm going to replace it in for this y right here. I'm going to substitute it in for y. And so I'm going to rewrite this equation here, which is y equals, but instead of writing y here, I'm going to write what y is equal to over here, which is 11,000 people, or 11,000 times x plus 145,000. That's y here, and that equals negative 6,000x plus 349,000. And so now I have this equation. And so I have two x's. I have to get the x's on the same side of the equation. And so what I'm going to do is add 6,000x to both sides. And the reason I'm going to do that is because now those will go away. Negative 6,000x plus 6,000x is nothing. And so I'm going to have 11,000x plus 6,000x, which is 17,000 times x. I still have the plus 145,000. And that equals the 349,000 on the other side here. And so I want to get this x here by itself, so I'm going to get rid of adding 145,000. I'm going to subtract 145,000 from both sides. So these 145,000s will cancel out, and on the left-hand side I will still have the 17,000 times x. That's going to equal 349,000 minus 145,000, which is, let's see, that's going to be 204,000 people. And so now I'm just going to divide everything by 17,000 to figure out what x is. So if I do that here, these 17,000s will cancel out, and I will have 204,000 divided by 17,000 is 12. So that means in 12 years, that's what the x represents. In 12 years, they're going to have the same population. And so I could plug 12 into both of these equations. And I believe if I plug 12 into both of these equations, Metropolis will have a population of 277,000, and so will Gotham have a population of 277,000. And the two cities will have the same population in 12 years. Let's go on, let's take a look at a different problem. So here we have a different system of equations, and we're going to solve this by substituting. And so just like we did before, I know if I take a look at the first equation, I have that y is equal to negative 3x minus 1. And what I'm simply going to do is this. I'm going to take that and I'm going to substitute it in for this y down here. Since in the first equation y is this, whenever I see a y, I can write down negative 3x minus 1 in its place. And so I'm just going to take this second equation and rewrite it. It's y equals, but instead of writing y, I'm going to write down negative 3x minus 1. And that's going to equal 2x plus 9. And so now I'm going to add 3x to both sides. And so I'll have negative 1 is equal to 2x plus 3x, which is 5x plus 9. If I subtract 9 from both sides, then this is going to be negative 10 equals 5x. And if I divide both sides by 5, then I will have x equals negative 2. Now that's not my solution because again my solution is a point. And so these two graphs might intersect at this point, but I want to know what's the x and the y for that point. And so I need both the x and the y. And so my x is negative 2. To figure out what my y is, I could plug in negative 2 for either this x in the first equation or the x in the second equation. I'm just going to use the x in the second equation. My y is going to equal 2 times x, but x is negative 2 plus 9. Well, 2 times negative 2 is negative 4, and negative 4 plus 9 is 5. So y is 5. And if I plug negative 2 into this equation here, I should get the same thing. Negative 3 times negative 2, well, that's positive 6, and 6 minus 1 is 5. So my solution is the point negative 2, 5. All right. Let's try example here 2 and 3. And what I want you to do is pause the video right now and try these on your own. See if you can figure out what the x and what the y are, and then start the video and see if you got them correct. Hopefully you've done that, and now I'm going to go ahead and start with number 2. It says that y is 5x minus 9. So what I'm going to do is just stick that 5x minus 9 in for this y. So I'm going to write this as 2x minus 4 times y, but y is 5x minus 9. That equals negative 18. And so I'm going to have 2x. I'm going to distribute to get rid of my negative or my parentheses. Negative 4 times 5x is negative 20x. Negative 4 times negative 9 is positive 36. And that equals negative 18. Well, these are like terms. I can put those together. 2x minus 20x is negative 18x plus 36 equals negative 18. I want to get the x by itself, so I'm going to get rid of adding 36. I'm going to subtract 36 from both sides. So negative 18x is equal to negative 18, and negative 36 is negative 54. Then if I divide everything by negative 18, I will get that x is positive 3, because a negative divided by negative is a positive. Well, there's my x value. Then I need to figure out what my y value is. So I'm going to go back to this top equation. I'm going to replace this x here with a 3. It's going to be y equals 5 times 3 minus 9. Well, 5 times 3 is 15, and 15 minus 9 is 6. So x is 3 and y is 6, and I can write it like that, or I can write it like this. Let's take a look at number 3. Same thing. I have that y is equal to negative 4x minus 2. So I'm going to rewrite the second equation, which is 5x plus 2y. But instead of putting y there, I'm going to put negative 4x minus 2 equals 5. Because that negative 4x minus 2, that is what y is. So I'm just substituting that in for this y. And so I'm going to have 5x plus, well, that's going to be negative 8x. And then 2 times negative 2 is negative 4. That equals 5. 5x minus 8x is negative 3x. If I combine my like terms, minus 4 equals 5. Then I'm going to add 4 to both sides to get rid of subtracting 4. And I'll have negative 3x is equal to 9. If I divide both sides by negative 3, then x is equal to negative 3. But then I want to figure out what y is. And so if I use this top equation here, I have y equals negative 4 times negative 3 minus 2. Well, negative 4 times negative 3 is positive 12, and 12 minus 2 is 10. So y is 10. And my solution is negative 3, 10. That's a comma there. Negative 3, 10. All right, so let's try one more example here. This one's a little bit different, maybe a little bit more challenging because I don't have y equals something or x equals something. But if I look at this equation here, I could really easily get this x here by itself. And that's what I'm going to do. I want to get something that I can plug in for either x or y, which means I need to solve an equation for x or y. And so if I add 2y to both sides to get rid of the 2y, I will have x equals, and I'm going to write this as 2y plus 11. So now whenever I see an x, I can replace it with 2y plus 11. I could substitute 2y plus 11 in whenever I see an x. So if I take the top equation and rewrite that, that's going to be 3 times x, but I'm not going to put x there. I'm going to put down what x is equal to, which is 2y plus 11. Then I have plus the 2y equals 1. So I just rewrote this equation, but I replaced this x with what x is equal to, which is 2y plus 11. So now I'm going to distribute here. I have 3 times 2y is 6y. 3 times 11 is 33. Plus 2y equals 1. Well, 6y plus 2y, that's 8y. Plus 33 equals 1. If I subtract 33 from both sides, then I will have 8y equals negative 32. And if I divide both sides by 8, then y is negative 4. That's half of my solution. Then I want to figure out what x is. So I'm going to go back to this equation here. I have that x is equal to 2 times y, and if y is negative 4, then it's going to be 2 times negative 4 plus 11. Well, 2 times negative 4 is negative 8 plus 11, and negative 8 plus 11 is 3. So that means that x is 3 and y is negative 4. And that's my point that is a solution. So this is what assignment number 2 is about. You can work on your homework assignment, and we will see you tomorrow in class.